Good morning, good afternoon, and good evening, everybody. Thank you for joining today's webinar on PTP 820. I'd like to introduce today's presenter, Alan Yu, who is Director of Product Management at Cambium Networks. Alan, you can take it from here.
Okay, thank you, Olivia. Good morning, good afternoon, everyone. So today's webinar is more about how we add capacity using the 820. I think this is a little bit, I want to run this a little bit different compared with normally we do, because this is, I'm going to spend some time talk about it, but then, we're probably going to spend a lot of time on Q&A. Because many things I think it's some of them they're obvious, some of them maybe I do not know you guys' situation. So this is more like open idea to do the brainstorm. I threw some of the idea. I know this will definitely help, but some of us, if you have such a specific situation, maybe we could talk about how to solve your own, your specific issue, or how we can do in the best economic way to help you. So very high level, if you have a microwave deployed or you need to add a new microwave, there's many ways you can add more capacity. Something sounds very obvious, let's just go through this list here. You can upgrade full capacity if you already have a link deployed. Say you have a link for, you deployed license for 500 meg, but when you get the license key, you only pay for, say, 100 or 300 meg. And now you can upgrade to the full capacity, so you can release the capacity you're not in use before. But you can't, if you're licensing from SEC for low capacity, you can't just add capacity key to get extra thing. It's all based on your license. The license, the channel, the modulation, all those things you get from FCC. If you have extra thing, you can definitely open it. The second thing is you can, if you have an old radio, because many of the old radio, they're not working on high modulation, so you can replace those radios with 820 to get extra capacity. The third thing we're going to talk about, is MU-MIMO, because in many places the spectrum is limited. You can't get extra spectrum, but you want to double the capacity. And the 4x4 line offset MIMO is a way to double the capacity without extra license, channels you need. We're going to talk a little bit more about that. And then we will also talk about advanced frequency reuse. This is another way you can add capacity. Basically combine the channels or get rid of the in the dense area, get rid of the limitation for the angle separation. So we're going to talk about that one as well. The last one I'm going to touch is the multi-band setup. So if you have a microwave deployed today and you want to add gigabits capacity, you can add an E-band on top of that, and we will do the aggregation. So you leverage the E-band for capacity, and you still have the microwave give you the availability to make the connection in the case when E-band link lost. So we're going to talk those 5, and then we're going to jump to the Q&A to see any specific questions we can address. So first one, this is very, very simple. This is basically you upgrade to a full capacity key. If you're using a 60 megahertz channel, the full capacity key you need is 500 meg. If you're running an 80 megahertz channel, your full capacity key will be 650 meg. If you're not there yet, you can buy the key to unlock the capacity there. The second thing is enable ACM. This is another very easy thing to do. Some of our customer they're using fixed mode because they don't want modulation change. So in our ACM, you can set up the highest and lowest modulation. If your highest modulation is not set up to 2K QAM, then the radio, even in a good day, no rain, the radio will not go to higher modulation. It will stay with your fixed. So very easy thing, change to 2K QAM for your ACM. The third thing is basically if you're using an 820C, 820C is a two-core radio. And we have customers deployed 820C before as 1+0. So simply, with a license key, you can upgrade to a 2+0. But make sure, you have the license in place. If you're licensed for only for 1+0 from FCC, you do need to go through the license process to get the second channel enabled. This one basically show how you do it. If you have a link deployed today, and it's a 1+0, you just need buy the license key, including the secondary core activation, include the capacity key. In the case XPIC, you will buy the XPIC key as well. Then you can remote log into the radio and do the activation. Depending on the radio setup, if your profile already been selected before, when you turn on the secondary core, you don't even see a down link is down. Actually, the original 1+0 link is in service. But if you're, let's say if you don't have the transcript set up properly, then you probably do need a reset of the radio in order to bring the, like XPIC, you do need a reset in that case to bring the secondary core activate. No site visit, it's pretty simple and easy. Okay, this is the this is the most easy way for a capacity upgrade. The second thing is let's talk about existing deployment. So let's say if you have a link deployed using aged microwave, say 5 years or 10 years before, you have the radio deployed. Some of those radio are old, and some of the radio they can only do to 256 QAM, or some very old radio they only do 64 QAM. So when you change to replace those radio with newer, the radios like 820, then you will be able to get more capacity. A good thing is we're trying to reuse as much as we can, so we can provide adapter or a converter to reuse existing antenna. So a converter basically is you keep the dish as is, you replace the feed horn, the whole plate, and convert this one to a direct mount for 820. And we support CommScope and radio wave dish for both 6 to 20. CommScope is 6 to 38 gigahertz. Radio wave is 6 to 23 gigahertz. Covers from 1 to 6 foot. This is the way actually I recommend, because this will have the most clean installation. The second way is you can do an adapter. So we provide two adapters. One is a Ramac adapter. One is a Dragon Wave interface adapter. Adapter means is you're not changing anything on the antenna. You keep the original interface as is. You just put a new adapter. A new adapter basically will be clipped to the old antenna, but it will convert to an 820 interface. And we also have this coverage from 6 to 23 gigahertz. And the thing of this one is you do add another layer between the radio and the antenna. It's a short waveguide. We really don't see much loss added. But the thing is, then you're gonna attach a radio for 1+0, 2+0. It works. It's just not as clean as the converter one, because the converter one basically, it's a direct mount. Everything is, like a direct mount dish. So it's much clean from installation point of view. So this is the second one. The third one is not everybody can get additional spectrum. In many places, you run out of spectrum. So let's say you got a 30 or 40 or megahertz channel, you don't have any way to license for 80 megahertz channel, and there is no second channel even available there. In that case, we have the line of sight MIMO support on 820C, and what we do is we can use exactly the same channel and double the capacity by separate antenna on the transmit and receiver side. So with a single, say 30 megahertz channel, we will be able to do 1 gig. But of course, because we're using the space diversity, we have to leverage that, so your equipment was doubled because you have 2 dish, you have 2 radios on each end. So there's a cost on the equipment, but basically we can convert an impossible way to a possible path to double the capacity, because you can't, no matter how much you want to double, if there is no spectrum, there is no spectrum, right? So but if you have one channel or a channel with XPIC, you can simply do the MIMO thing to double the capacity. So let's talk about a little bit detail. We don't want to talk the details too much, but just give the idea. The way how you can double the capacity is also have the dependency for the antenna separation. So you can see is there's a formula here. Ideal separation is determined by the distance, by the frequency, and it's D times C divided by 2 times F. So this one, let me get my pen here. So this one gives you the ideal. This one gives a number for ideal antenna separation, the square of antenna ideal separation. Then you can do the, on each side you have H1 and H2. So set 1 is H1, set 2 is H2. As long as the product of the H1 and H2 equal to the optimized separation, then you will get the, basically double the capacity. If you're not able to, due to the limitation for the antenna or the site setup, then as long as they're meeting 70% of that, you can still get, even let's say the ratio is only down to 50%, you can still get 70% capacity increase. So, in most cases, we see customers ready, on this side. We see the real deployment we have is about 80 to 100% capacity increase. So, and also this chart gives you the idea, the lower the frequency, the separation go higher. So if you do say 10 miles, then for 6 gigahertz, your antenna separation is 60 feet, which is pretty wide. So the higher the frequency, actually it will lower and make it more realistic. So so this is the line of sight MU-MIMO, not MU-MIMO, line of sight MIMO for 820C, and you can double the capacity using the exact same channel. That's an advantage you can get. All right, so let's talk about next point. Next point is the AFR. So AFR is a tool, or it's not a tool, it's a feature. We will be able to further, increase the capacity. But this is more fight about angle separation. In the normal angle separation, like if you have a link deployed like this, a hub site with remote site like this, they're all point-to-point. If the two sites is too close to each other, you have to run separate channels. You can't run it on the same channel. In order to reuse the same F1, the angle separation, the minimum angle separation required, I think was about 70, 80 degree in order to ready, frequency reuse in F1 here. Okay, so basically in this case we show you have to run 4 different frequency because they're all adjacent, or 2 adjacent to each other. And with AFR, it's a feature you can turn on 820 radio. So with AFR, basically we eliminate the angle separation down to 15 degree. So basically I can reuse my channel. This 2 site, I can reuse this channel as long as angle separation is 15 degree. In that case, I can, if I compare with the previous one, I could use a wider channel because, in the past, I have to go with narrower channel because I don't have enough channel. But in this case, I can use a wider channel. So in 2 parts, I can use a wider channel to give me more capacity. And also I can use a narrower angle because I can reuse the frequency. Okay. The AFR technology, fundamentally within the AFR, how it works is really, it's like the XPIC. Although the XPIC, we have the radio, it's a single radio, and we using the cross-pole cancellation technology to get rid of the interference. In the AFR, it's similar like that, but it's not identical. Basically, we will be able to feed the interference back to the hub site, and hub site will do the pre-adjust and send to the remote. By doing that, we will be able to achieve a good performance without by reducing the angle separation. And this chart shows, with the with the AFR, because of the AFR, we will be able to, reduce the interlink interference by 30%, and that is the way how it works. Basically, we will be able to achieve a pretty solid performance. Even the angle separation is only 15 degrees. So we talk about four ways so far. Full capacity of the existing link, and we talk about the replace the old radios with newer radio, so you can get extra capacity because of the newer technology is better, and not only type of modulation. We also have header compression, so those kind of things will help you. The third thing we talk about is a 4x4 MIMO, so you can run it on the same channel, but it can double the capacity. The first one we just talked about is AFR here, advanced frequency reuse. So reduce angle separation from 70-80 degree down to 15 degree, and with that we can using the a wider channel, or we will be able to serve multiple links in a dense area. So next one is the fifth way. This is a little bit different because all the previous one we're talking about is microwave. In this case, we talk about microwave with E-band. So we all know E-band is running on 70-80 gigahertz, and which is very prone for the heavy rain. You can't really deploy a link for very long distance if you still want 4.9 or 5.9 link availability. So what we have done is we're going to support this multi-band, meaning is we will make a link. Actually, there's two links in there. One is a microwave link, one is a millimeter wave link. The E-band radio will provide us with high capacity, but microwave link will provide us with high availability. So a very different compare ours with some other vendor solution is we're doing the aggregation, meaning is both link is transmit simultaneously and the traffic is divided between those two links, and we will send over the two link and recover data on the receiver end and regroup them, so send to the user. So from user point of view, it's a single pipe, although it is really two different pipe. One is an E-band pipe, the other one is a microwave pipe. The good thing for that is we will be fully utilize the capacity there, rather than like a failover when the E-band is not working, then we're using the microwave. In our case, we're using all the investment we already put in there, and all the the data is transmitted simultaneously over the two, over the two link. So you get an extra one. So there are something we need aware. Okay, number one is it will be more smooth working with 820 radio for this multi-band, because the 820 and the 850, the E-band radio, we support bandwidth notification, meaning is we will be able to tell the other radio what is my air capacity. So the data balance, when we rebalance, when we divide the data over two link, we know how we want to divide. Okay, so it works. The best performance is using all the Cambium microwave and the Cambium E-band. but we do support third-party microwave as well. So when we work with third-party microwave, number one is that link has to be a pipe link, meaning is you're not doing the switching things, because we want the data to be passed through with low latency, and we don't want those switching things happen there. So the third-party microwave need to be set up like a bridge, like a layer 2 bridge. The second thing is we do need a 8023AX flow control, because we don't know what the third-party microwave capacity is. Radio don't talk to each other. The only way we can do is using the flow control. So when we send more data, they're gonna push back to us. So then we know, okay, this is roughly this microwave link can really handle, and then we will be able to divide the data between two links. Of course, there's some other additional setting on our microwave E-band radio, which is automatic state propagation, and that needs to be turned on. So this is the way we work. We can work with ourselves, with third party. The other thing is, because the data is sending on both link, okay, and it'll be recovered on the receiver end on the E-band radio. The buffer will be there to regroup the data and then to send the data in the order to customer, because we all know that Ethernet data is in order. You can't just mess around, then there will be trigger a lot of retrans. So the latency difference requirement is 1.6 milliseconds. If you turn on the adaptive coding modulation, you want to make sure from your highest to your lowest, you're still within the range. Otherwise, you should limit your ACM so your jitter is not too big. Otherwise, you will see the out of order. Then it will trigger retrans. Then eventually, your real capacity will not be the one you really want. So we have people asking is, can I using my E-band with a 5 gigahertz radio? The answer is no. Most 5 gigahertz radio, they're TDD radio. The latency is too much. Basically it will not work. All the data sent on 5 gig, they will be retrans. So it doesn't really work. So you have to make sure the latency is within the 1.6 millisecond. That's a magic number you need to remember. So the whole idea is very straightforward. You set up the radio using the high capacity for the E-band. Meanwhile, you are using the microwave at the same time. But when the E-band data capacity going down due to the rain impact, you still have your microwave there. When you lost your E-band, you still have your microwave here. So microwave ready is for your, keep the link up. And the E-band gave you the normal operation high capacity, because without rain, your E-band will be pretty solid for that configuration. This is the one we did in US. This is a 2.8 miles link with rain zone K. We're using a 2-foot dish with 18 gigahertz, and this is what we have achieved. Okay, so a little bit more how the link was, how the setup looks like. So on the microwave link, let's see, we put an 820C here, then we run the MCBC, and then we do the link aggregation. So all the air capacity is mapped to a single port, and then this Ethernet port will be connected to the E-band radio. Okay, so we have a 1 gig interface between microwave and E-band. On the E-band, we run a feature called Enhanced MCBC, because MCBC is ready to layer 1 aggregation. In this one, in the 820C side, MCBC is ready to combine the microwave, the air interface, to one pipe to this port. And the enhanced MCBC is basically, we will be able to treat this Ethernet port and the air interface together and combine them to provide a connection to the secondary data port. So from this port, it will be a 10 gig interface to the customer side. And the data, when the data sent to the MCBC scheduler or algorithm, the data will based on the air interface of E-band and also the microwave capacity. The data will be split here. And then on the receiver end, once data received on the, on both sides, same way, it will be regrouped, sent out to the customer side. And the radio is PoE, so we, in this case, we're using we run the PoE for 850, 820 microwave, and 850 or 820E for E-band. You could using a single management thing. In that case, basically, you're gonna run another cable to another port here for management. So in that case, you will not have the management here. You only do the PoE. Then the management can go here, and then you do a single port for management for the configuration. So up to you. But the idea is the E-band. The E-band is really your host radio, and your microwave is additional connection. So this show you a setup looks like. We can do separate antenna. We can do single antenna. For single antenna, we have 18 and 23 gigahertz with 80. So in that case, the E-band radio will be direct mounted here, and the micro will be direct mounted here. So it's a single dish, but we run dual band. If you run two separate antenna, it doesn't matter. You can have more flexible choice if you do the separate antenna, especially when you run with third-party microwave. You have to go with separate antenna. In that case, your E-band radio is your host, sent to the customer side, and then you have there's a 1 meter fiber jump cable between the microwave and the E-band. Okay. That's all I have. I mean, basically, as I said earlier, I just threw some ideas, and I like to see, if there's any questions or issues specifically you have, and it's not touched here for the options or the ways you can upgrade capacity, or if you have some good ideas, please share with us. Maybe there's something we didn't realize. We can also do the capacity upgrade. All right, I guess we're all good. So thanks everyone, and hope you all have a good day. Thank you.